the word, or the word's already there, independent variable. And go to write this definition there. The variable represented by the horizontal axis. Scoriola. The variable represented by the horizontal axis. Now, what do I mean by the horizontal axis? Well, the horizontal axis is this axis, the x-axis. That's always going to be your independent variable, the x. So the number line that starts at 0 and goes left and right, that's your horizontal axis. Go and do that on your notes. That's always your independent variable. Whereas opposed to the dependent variable, it's the variable represented by the vertical axis, which is your y-axis. You have a vertical axis, which is your independent, and you have your vertical axis, which is your dependent. I'm going to write that in. 1, -1. -1 on this side, +1 on that side. So I'm just giving you a simple number line. Horizontal means left and right. Think of the horizon, the sun coming out of the horizon. That's horizon from left to right. Vertical means up and down, the vertical axis. Sometimes you guys call it the y-axis. Yeah, this Ariola? From Thursday? These last 2 words there. Sure. There you go. Earphones off. We're just going to do a simple circle map, and we're done with notes for today. So we're going to write just put a circle in the middle of your paper. Write the word functions. Perfect. Functions. Now remember on Thursday we talked about this one thug? Remember the Pomona thug? The Pomona thug. Remember the thug on Thursday? Maybe you weren't here. The thug on Thursday, recall he was running away from an old lady. Remember how fast he was running? Adiola? Does anybody remember how fast he was running away? How much feet per second? 4 feet per second. So at the first second, he's 4 feet away from the old lady he stole the purse from. 2 seconds, he's 8 feet away. So we can use a function to describe this thug running away from the old lady. A function can be described in various ways. It could be described by a graph. So out here on the outside the circle map, let's go ahead and put by a graph. So there's different ways to describe a function. One way is a graph. We're going to put an x and y axis, a little x and y axis here. Doesn't have to be like a Picasso drawing. So at 1, going to put 4. Let's do so look what I'm doing. I'm just drawing a little graph. So a function can be represented by a graph, put an x and y axis. And going to put some points with me, just like this, kind of like with the thug example. Let me put a little line there. How else can a function be described? Well, we did it for warm-up. How about an input-output table? We're going to put x and y. So put input-output table. Input-output table. So at 1 second, the thug was 4 feet away. At 2 seconds, the thug is 8 feet away. At 3 seconds, the thug is 12 feet away. There's an input-output table. So a function can be represented by a graph. It can be represented by input-output table. It can be represented by ordered pairs. So over here, put ordered pairs. You're going to take up your whole paper for this? What's the matter? Look at ordered pairs that we graph. Look at, I'm going to separate the numbers by a comma in parentheses. 1, 4, 2, 8, 3, 12. So ordered pairs. So we got input-output table, ordered pairs. We got a graph. These are the way functions can be represented. How about in words? We can describe the function in words. So graph, input-output table, ordered pairs, words. Watch this. Our function's describing a thug running away, right? So look at the words I'm going to use to describe this function. A thug, I'm talking please. A thug runs away at 4 feet per second. Notice I'm describing now the function in words. We're describing it in words. We're describing it in a graph. Input-output table, ordered pairs. From Thursday, I passed it out? Okay. Circle map. I'll hole punch it later. Just give me the circle map here. Sorry? Not yet. So far, so good. How about by an equation? Graph, ordered pairs, 3, yep. Last one will be an equation. Let's write the equation that describes this thug running away from the old lady. This meanie. What a meanie. So the equation of the thug running away from the old lady, let's see here. The feet is y. So here's y. And the seconds is x. So what's the relationship between y and x? I'm going to create an equation that describes the number of feet the thug is running and the number of seconds, how they're related, y and x. Kind of like we did in warm-up. We had an equation y equals 2x minus 3 or something like that. I'm going to create an equation that describes the thug. Watch this. Y equals 4x. Write that down. Believe it or not, that equation describes a thug running away from the old lady. Y equals 4x. So a function can be represented in 5 different ways. But let's also add some features of a function. So down over here, I'm going to put an arrow. So here's the way it can be represented. Now I want to talk about some specific features. Just a minute. For every input, there is exactly one output only. Put exactly, underline like 3 times, exactly one output only. For every input, there's exactly one output only. So we got 6 items on this circle map. The 5 ways a function can be represented, and then there's one characteristic. For every input, there's exactly one output only. So -2 goes with 2. -1 goes with 2. 0 goes with 2. 1 goes with 0. 2 goes with 0. For every input, is there exactly one output? In other words, is there any inputs that are repeated? So this input has exactly one output. So out of all the 5 points, 2, 3, 4, 5, every input has exactly one output, so this would be a function. So this would be a function. So go to write on your notes, function. Yes, function. For A. And the reason why it's a function is because every input has exactly one output. But look at B. Look at relation B. B is not a function. Check it out, Valdez. B is not a function because look at 4. 4 is one input. It has an output of 0, but notice how 4 also has an output of 3. So the input of 4 has two outputs, 0 and 3. So this would be not a function. I'm going to write not a function for B. Because look at the input of 4 here, and the input of 4 has two different outputs. In other words, it doesn't have exactly one output. That's how you can tell whether a relation is a function or not. How about C? This relation of C, this table. Does every input have exactly one output, Rodriguez? Stay with me. No. Which one has a different output, Garcia? Right, look at the output of 0 here and the output of 0 there. This output of 0 has 5, and the same input has 6. So this would not, just put no on this one for C. C would be a no. And last but not least, look at D. The input of -1 has only one output. But notice 3 and 11. They have the same output, but it's still a function. So this would be a yes. Because even though 3 and 11 have actually have the same output, every single input has exactly one output. So this would be yes. A function. Because every input has exactly one output. It just so happens that 3 and 11 have the same output, but since they have exactly one output, it's a function.